Polynomial equations and graphs. First thing I want you to realize is that anytime I say finding zeros, that's the same as solving equations that are equal to 1, or it's actually the same as finding x-intercepts. And in fact, it's the same thing as finding the root or solution to f of x equals 0, or finding the x-intercepts of f of x. So anytime you see or hear zeros, roots, solutions, x-intercepts, they all involve having something equal to 0. So let's talk about polynomials for a second. Hopefully this is a review for you. Polynomial is nothing but a sum of terms. That means they're terms that are added or subtracted together. The degree is the highest exponent on the variables. So if you look at this example down here, the degree of this term is 4. The degree of 7x cubed is 3. And the degree of 2x is 1. And the degree of the constant is 0. And so, when we write polynomials, we do want them written in descending order by the degrees or by the exponents. 4, 3, we're missing the term, 1, 0. In fact, if we wanted to, we could actually insert that missing term. So anytime we're missing a term, because after 4, 3, we expect to see a degree of 2 or an x squared, which we don't have one, but we can put it in if we use 0. And then write down the remaining terms. That way we see 4, 3, 2, 1, then 0. The term that begins the polynomial is called the leading term. The one at the end is called the constant. The one that doesn't have a variable, because it will never change. All the other terms can change based on what x is. Now, the leading coefficient is the number in front of the leading term. That should only make sense. And then this highest degree, which is the degree of the whole polynomial, it tells you how many zeros, or at most how many zeros this polynomial has. And it has 4. In fact, you could actually say it has exactly 4. And then this that you may see is just telling you that it's written in decreasing order or descending order by the degrees. And you always end with a constant. So, let's look at some examples that we may have to consider. First thing you may see is something called leading coefficient test. Now, I'm going to tell you what it says. It says blah 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 blah. That's pretty much what it says. Let's look at f of x equals x squared. Here's the graph of it. Now, if you notice, the number in front of the x squared, you don't see a 1. It's understood to be a 1 or positive 1. And you'll notice that the exponent is a 2. In other words, it's even. What the leading coefficient test states is that if the number in front of the x squared is positive and the exponent is even, that means as you read to the left or as you go towards negative infinity, the curve goes up. It's increasing, or it rises to the left. Then as you go to the right, it's also rising. So sometimes if you just use basic examples, they can make life a lot easier to understand. So now let's look at f of x equals negative x squared. I'm going to use y equals, it doesn't matter. That one's going to be an upside down u. Now notice this time the coefficient is negative, but the exponent or the degree is still even. So if it's an even exponent with a negative coefficient, the negative is going to turn it upside down. That means as you go to negative infinity, it's falling. And as you go to positive infinity, it's also falling. So it falls to the left and falls to the right. So if you want to match these up, this one represents the first rule. This one represents the second one. Now let's look at x cubed. And it looks something like this. Once again, it's a positive coefficient, but this time it's an odd exponent or odd degree. That means as you go to the left, it's falling. And as you go to the right, it's rising. Imagine that. Is that not the craziest thing you've ever heard? Now let's do negative x cubed. It looks something like this. This time it's odd degree, but a negative coefficient. That means it's going to rise as you go to negative infinity or to the left. And as you go to the right or positive infinity, it's going to go down or fall. So this one represents number 3, and this one represents number 4 of the leading coefficient test. You'll find that if I ever make calculus videos, I'll use these 4 main functions to do a lot of explanations. Good things to know. But by far the most important thing for this is actually should be a review for you. It's how to solve the following. It's the same thing as finding the roots, finding the solutions, finding x-intercepts. It's all the same stuff. So hopefully a lot of this will be review. We're going to solve 0 equals x minus 2. I easily could have asked you to find the x-intercepts of x minus 2. If I had, you would have said x minus 2 equals 0 and solved. So this is all the same kind of question. And all you do is add 2 to both sides. Now when I say compared to the graph, what that means is if I were to graph x minus 2, I'm saying that it's going to cross the x-axis at 2. And it looks like it does. Now if you're not for sure, there's a couple ways you can look at it. Hit second graph. The table shows that when x is 2, that we have our 0 that we're given the problem. You can also hit trace 2 and do it that way, which I prefer. You can also do this. I've made other videos about this, but I'm going to show you again. If I hit enter 0, which means I'm going to actually graph the x-intercept, but you can't see it because it's already graphed. If I hit second trace intersect, I can just hit enter 3 times. And it tells us the intersection is 2, 0 or x equals 2. This all means the same stuff. There's another way to do it, but this is actually the easiest way, the way that I just did it. Let's do B part. Now on B part, you'll notice that this is already factored. Hopefully you see that. So we have two factors, x minus 2 and 3x plus 4. Now these exponents just mean that if I were to write it out, it'd be x minus 2, 3x plus 4, 3x plus 4, 3x plus 4. I don't need to solve all 5 of those when all I need to do is solve 2 of them, the 2 distinct factors, by setting those equal to 0. Once again, I'm going to add 2 to both sides. We get x equals 2 for this one. Over here, I'm going to subtract 4. And then divide by 3. And we get our second one. So we got x equals 2 and then x equals negative 4/3. Once again, if you want to see that on the graph, I can type it in the way it is. I don't want to type it there. It's just be consistent. X minus 2 raised to the second power. I could have used the exponent of 2 over here if I wanted to. Doesn't matter. 3x plus 4 raised to the third power. I could use a math key if I wanted to for a cube. Doesn't matter. Now, sometimes you see funny looking graphs, and that's a reason why you may want to learn how to do things algebraically. But if you're just doing this to check, you can hit 2, enter, and get 0. You can also hit negative 4 divided by 3. And hit enter. See that? We still get y equals 0. So watch out. Sometimes these graphs are funny looking. Sometimes you hit zoom fit. That helps things. A little bit, but not really. Zoom 6 takes it back. So by far, algebra is the best way to do these. Now let's say that you're someone that you're obsessed with a calculator, and you can find out that's not a good thing. And you just type in x squared minus 26. Bad things are going to happen. Now, your first reaction may be, I'm going to look at the graph or the table and see if I can find anything, and you don't see anything that's giving you a y equals 0. Nothing. So you get a little scared. So then you go to y, enter, and you type in 0 because you know that's the easiest way to do it with the calculator, because you can use the intersect key. The reason why I need two of them, because the intersect is where two lines intersect. So in the first curve, I'm actually going to move it to where it's close to the left. Actually looks like it's about -6, so instead of moving, I just hit -6. Oh, no, I can't either. You learn things every day. Hit the second trace, intersect, and I have to move it. So where it's pretty close to it, hit enter 3 times. Ooh, that's an ugly decimal. Let's see what the other side looks like. Using right arrow keys, don't use left and right, just use right. By the way, I know it's going to be close to 5 something, so I'm actually, as I hit the right arrow, I'm watching the X change. And when it gets close to 5, I'll start seeing the cursor flashing. See, it's now at 3. 4, now let's see that, it starts popping up, see that? So I'm just going to hit enter until I feel comfortable where I'm at. Ooh, ugly. What that means is that your answer isn't going to be a nice answer. It's going to be a radical. So here we go. We're going to solve this, and this is hopefully review for you. And I'm just now thinking that I want to link a video on how to solve certain things, but there'll be so many videos. I'm just hoping that you know how to do this. Once again, we're going to isolate the x squared like we did up here with the x, but now it's x squared, so we get 26 equals x squared. And to solve this for x, we need to get rid of the exponent, so we do that by square rooting both sides. But there's something to remember, anytime you take the square root of both sides, plus or minus. So our two answers are plus and minus. I'm not sure what that is. It was supposed to have been a square root symbol, but sometimes it just doesn't turn out the way you want them to. Plus or minus square root of 26. Let's go back to our graph. See that 5.099 blah blah blah. What's this? Remember 5.099 blah 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 blah. There it is. Matches up. So it was a square root answer. No decimals. We don't want decimals. Now on this one, I'm going to solve it by factoring. First thing I notice, and by the way, well, I can't use the quadratic formula here because of the cube, so I have to factor. So if you notice that all three terms have a 3x in common, so when I divide each of those by 3x, I get x squared plus 4x plus 4. And then I can continue factoring or use a quadratic formula in this part. And it's going to factor as x plus 2, x plus 2. And you can actually rewrite it like this if you want to. Which means to find the answers for 0, I set each of those factors equal to 0. Since I have 2 of these x plus 2's, it suffices to only solve one of them. Now to solve 3x equals 0, we divide both sides by 3, and we get x equals 0. Subtract 2, and we get x equals -2. Once again, if you're not sure about your factoring, you probably do want to use your calculator. Hopefully you have an instructor that says, that's okay, go ahead and use it. If you don't, you better learn how to do this algebraically. So we have 3x cubed plus 12x squared. I'm just typing in the original problem. I'm not worried about anything else. And if you notice, it looks like it's crossing at -2 and 0. First thing you may want to try is the table and see. Boom, there it is. -2, we have y equals 0, and x equals 0, we have also y equals 0. No other places. Well, would you look at that? So we're done with that one. Some of your instructors are going to hate me for showing you how to do it with the calculator. And look at that. We got one more to go. This one will factor. And the reason why I know it factors is x to the fourth can be thought of as an x squared. So you're thinking what times what is 8? That gives you a minus 6. Well, you're thinking 2 and 4 will, if both of them are negative, because the negative times the negative is a positive 8. And when you add them, you get a negative 6. So it will factor as x squared minus 2 and x squared minus 4. Now, x squared minus 2 will not factor, so I'm going to leave it like that because of the 2. But x squared minus 4 will factor because of the minus 4, because that's the same as x minus 2 and x plus 2. Now what that means is I'm going to have to set each of those equal to 0. But let's just say something. Let's just say that you're really not comfortable with your factoring. Even though I just factored it. Let's say that you're not. What you could do is you could just take each of those, x squared minus 2, set that equal to 0, and then x squared minus 4, and set that equal to 0. Some people would prefer to do this, so you're going to add 2 to both sides. You get x squared equals 2, and then you're going to have to square root both sides to get rid of the exponent. Don't forget plus or minus. So you're left with x equals plus or minus square root of 2. And then over here you do the same thing, except you add 4. You get x squared equals 4. And then you're going to square root both sides. Don't forget plus or minus. And you get x equals plus or minus 2. So we actually have 4 different answers. And one way to realize that you do is because of this degree. 4 is the highest. So you're looking for 4 answers. Now this one up here actually had 3. It just so happened that this minus 2, there's actually 2 of them. We'll talk about that in a later video if you stay with me. So we have our 4 answers, plus or minus square root of 2 and plus or minus 2. Let's just look at the graph. You want to? So we have x to the fourth minus 6x squared plus 8. Now you see it across in 4 places. So let's look at the table. We see the negative 2 and we see the 2, but we don't see the square root of 2. So once again, what you can do is we hit enter, 0, second trace, intersect. I'm going to move it until it's about right there and hit enter. About 3 times. Oh, I made a mistake. I hit it plus. Oh, if you mess up like I did, it doesn't hurt to start over. So, okay, enter, enter, enter. See that negative 1.27659? That's the same thing over there, so it's going to be positive. Negative 1.27. Ooh, made a mistake somewhere, didn't we? And you see the mistake? I don't either. Let's do it again. Enter, enter, enter. Oh, I'm hitting the wrong one. Oh, don't do what I do. Hit the intersect. Learn from my mistakes. Enter, enter, enter. And there it is. Negative 1.414. Negative 1.414 if I do the right side. Oh, learn from my mistakes.